So I want to bring on Shai, who also is going to show how you can make developers' lives easier, because he's going to talk on how to make Kubernetes easier. Now, when you pair it with Kubernetes, with GraalVM, you have the ability to start up your containers in a very small amount of time. And Shai is going to show us some toolkits and technologies on how to make that easier. So, Elena, thank you so much for this. I now am going to spend a considerable amount of time following you and reading about all your incredible material on that. And Shai, over to you. And thank you again, Elena.
Thank you so much, Rory, and good luck, Shai.
Great talk. I'm very excited about GraalVM as well. And as you said, Rory, it's indeed a very interesting time and very connected to one another. So, hello everyone, I'm Shai Almog, and today we'll talk about debugging at scale in production, specifically about Kubernetes debugging. I'm assuming everyone here knows the basics of Kubernetes, so I will dive right into the basic problem description and then into the 3 tools I will show today. But first, a few things about me. I was a consultant for over a decade, worked at Sun, founded a couple of companies, wrote a couple of books, wrote a lot of open source code, and currently work as a developer advocate for Lightrun. My email and Twitter account are listed right here, so feel free to write to me. I have a blog that talks about debugging and production issues at talktotheduck.dev. It would be great if you check it out and let me know what you think. Containers and orchestration revolutionize development and production, no doubt. But in a way, Kubernetes made debugging production issues harder than it previously was. In the past, we had physical servers we could just work with, or even VPSs. Now we face much greater difficulty in this age due to 3 big challenges, again 3. The massive scale enabled by Kubernetes is a huge boon, but it makes debugging difficult. We need new tools to deal with the scale. We now have multiple layers of abstraction to the deployment where failures can happen in the orchestration, container, or code layers. Each failure requires a different set of skills and solutions. Tracking the cause to the right layer isn't necessarily trivial. And finally, there's the barebone or lean deployment problem when debugging. This is the first problem I want to focus on. We'll get to the other 2 soon enough. It's the problem of the bare-naked container. We can connect to a barebone container, but we have nothing to do inside it. Nothing is installed. We can inspect logs, but that relies on luck. Furthermore, if your logs are already ingested by a solution like Elastic, you probably don't have anything valuable to do within a barebone container. kubectl debug solves these problems and can work even with a crashed container or barebone image. The kubectl debug command adds ephemeral containers to a running pod. An ephemeral container is a temporary element that you would vanish once the pod is destroyed. With it, we can inspect everything that we need in the pod. Most changes we do in it don't matter. They won't impact the pod after we're gone. It works with barebone container. The way it does this is with a separate image. So we can have an image that includes everything in it. The container is spun from the image, that's spun from the image is ephemeral and can include a proper distro and the set of tools that we need. kubectl debug was introduced in version 1.23. So if you're still in an older version, you will need to wait for that. If you use a hosted Kubernetes version, you will need to check the version used by the host. Let's start with a simple demo. As you can see, we have here a few pods. We're experiencing an issue and would like to increase the logging level so we can better see what's going on. I can use exec and log in directly to the live pod. I log in with a proper bash shell. I'm sure most of you did that in the past. It's really easy. Here I can just use standard commands like cat and grep to check logging levels. This is all good. We can see the current level is at info. Unfortunately, I don't even have Vim if I want to edit this file. Now when the container has apt or APK, and when the pod isn't crashed, I could, in theory, just apt-get install vim, but that's got its own problems and is a painful process. We don't want people in production just installing packages left and right. Even if it's cleaned up, the risks are sometimes too high. Pods shouldn't be touched in production once deployed. All the information and state of a pod should be described in its manifest, unless it's a strictly stateful pod like a database, etc. So installing like this is problematic. So let's exit for a moment and try connecting again with kubectl debug. I'll use the busybox image in this case, and we'll see how that works. Notice that this is the image referenced in the kubectl debug docs. So I'm connected to the pod again, or so it seems. Technically, I'm connected to a new ephemeral container and not to the pod directly. This is an important distinction. But as you can see again, I don't have Vim or really any of the tools I would expect like Visual VM, Traceroute, etc. I can fix that. I can create an image that represents everything I need and package all of the tools I need, then pass that image to kubectl debug and just use those tools. But here's the thing, I'm not unique. We're all pretty much the same. We all expect the same things in our debugging sessions. And that image I can use as probably the same image you would use too. So why not have one generic image? This is where KoolKits comes in. KoolKits was created by Tom Granot of Lightrun. KoolKits is an open source project that includes a set of opinionated, curated, platform-specific tools for kubectl debug. So you can have everything you might need at your fingertips while debugging. So what does this mean? When you use kubectl debug to spin up an ephemeral container, it's built using a KoolKits image. Currently, there are 4 standard images. A Go image that includes tools such as Delve, pprof, GoCalvis, and many others. The JVM KoolKit, which includes tools such as SDKman, JMXterm, Honest Profiler, Visual VM, and much more. The Node version includes NPM, NDB, 0x, VTOP, and much more. And finally, the Python version includes IEnv, IPDB, IPython, and again, much more. But this is just a tip of the iceberg, as all the versions include the many tools you would expect in any proper debugging session, such as Vim, HTOP, and also have a lot of networking tools such as Traceroute, Nmap, database clients for Postgres, MySQL, Redis, again, so much more. So let's continue from where we left off in the demo. We can disconnect the current session and then spin up a new session with the KoolKits image. Notice we can also use the shorthand KK command for many operations, which I don't use here. But you can see the syntax in the KoolKits docs. Specifically in this case, notice I used the JVM version of KoolKits, which I chose because I'm a Java guy and hopefully so are you. But if you're using a different environment, you can use what fits here. In KoolKits, pretty much every tool I want is already pre-installed as part of the image by default. This means we can just connect and everything is already there. Since we're all pretty similar in our needs, KoolKits includes the common things most of us need based on the platform or language. It has sensible defaults and comes with Ubuntu as the distro. This is important. You have a full distribution like you would have in a desktop or in a regular server. This is very helpful for debugging. So you get everything you need, even when debugging a barebone container. Notice that thanks to kubectl debug, we have full access to the main application's containers file system and the pod's process namespace. So we can do everything there while residing in a more convenient environment. It's having our cake and eating it. So to finish the story from before, I can just use Vim to edit the file and change the logging level to error, which I can then confirm using cat and grep. I can also do a lot of other things, such as profile using a profiler, debug with GDB, or JDB, I can use JMX term to perform JMX operations, which lets you configure the way the JVM behaves in runtime, and pretty much anything I can do in a local machine. To give you a sense of what KoolKits installs, this is the list of packages for the JVM client. And this is bound to grow as you can all submit pull requests with your favorite packages. This is just the JVM specific image. The other images contain similar tools at similar scale. And you can get all of that thanks to kubectl debug and KoolKits. What if what we're tracking seems to be an application bug? This is a common occurrence for sure. We might not know it at this stage, but that might be the place we want to investigate. We can try using logs and probably should start there. But more often than not, the issue we need solved aren't logged. We can try using various observability tools. They're great, but not for application-level issues. They rule for big picture analysis and container-level problems, not for application-level problems. We can use one of the debuggers in KoolKits to track it. That will only work if we know the server where the issue manifested, which we sometimes do know. It is remarkably risky connecting to a debugger to a production environment. It can lead to multiple problems, stopping on a breakpoint by accident using conditional statement that grinds the system to a halt, exposing a security vulnerability, etc. JDWP is the Java debugging wire protocol. There are several such remote debugging protocols. We can use it. It suffers similar issues, but we'll dive deep into this. So here's the first problem we run into with a debugger. We can't just start using it. We need to relaunch the app with debugging enabled. That means killing the existing process and running it over again. That might not be something you can just do. Furthermore, running in this mode is a big security risk. Notice I limit access to only the local server, but still it's a big risk. Leaving a remote debugging port enabled in a deployed server code is considered a huge security vulnerability. If hackers can ride a different vulnerability, they might be in a position to leverage this from a local system. Still, if we do this for a short period of time, this might not be a big deal, right? In a different window, I need to find the process ID for the application I just ran so I can connect to it. I can now type it into the JDB command, and now I'm connected with a debugger. I can add a breakpoint using the stop command. Naturally, I need to know the name of the class and the line number, but I can set a breakpoint to stop at. When stopped, I can step over like I can with a regular debugger. However, this is a pretty problematic notion on multiple fronts. First off, I'm literally stopping the threads accessing this application. That's probably not okay on any container you have in the cloud. There are ways around that, but they aren't trivial. The second problem is different. I'm old, so people automatically assume I love the command line. And I do to some degree, but I love GUI more. When I started programming, there was no option. We didn't have IDEs on Sinclair, Apple II, or PDP. But now that we have all of those things, well, I want to go back. I've programmed Java since the first beta, and this was actually the first time I used JDB. I use command line tools when they give me power, but debugging via commands, I just can't. The obvious answer is JDWP. We have a remote debug protocol that's supposed to solve this exact problem, right? But this is a bit problematic. If we open the server to remote access with JDWP, we might as well hand the keys over to the office to hackers. A better approach is tunneling. During the age of VPS, we used to just use SSH tunneling. Like this, we'd connect to a remote host and forward the port where the debugger was running locally. Notice that in this sample, I used port 9000 to mislead hackers scanning port 5005, although it wouldn't matter because it's SSH. We can do the exact same thing with Kubernetes using the local port forward command to redirect a remote GDWP connection to localhost. Port forwarding opens a secure tunnel between your machine and the remote machine on the given port. So when I connect to localhost on the forwarded port, it seamlessly and securely connects to the remote machine. Once we do that, I can just open IntelliJ IDEA and add a run configuration for remote debugging, which already exists and is pre-configured with the defaults such as port 5005. I just give the new run configuration a name, and we're ready to go with debugging the app. Notice I'm debugging on localhost even though my pod is remote. That's because I'm port forwarding everything. I make sure the right run configuration is selected, which it is. We can just now press debug to instantly connect to the running process. Once that is done, this feels and acts like any debugger instance launched from within the IDE. I can set a breakpoint and step over and get this wonderful debug GUI I'm pretty much used to. This is perfect, right? Well, not exactly. It's got quite a few drawbacks still. As we can see, there are so many problems in this process. First and foremost, the need to restart the process. We can probably run the debugger with the debugger turned on by default, but that is a huge risk. Then it's breakpoints. They break. I heard a story years ago about a guy who debugged a Rails system, and it literally fell into the ocean while he was stopped on a breakpoint because it didn't get the stop command. I don't know if that's an urban legend, but it's totally plausible. All remote debugging protocols are insecure, but I can personally attest about JDWP, which I'm familiar with. It's very insecure. In fact, there were CVEs already about products that left it open. It isn't designed with security in mind, but it's also a stability risk. Now, how many times did a debug process crash on you? Imagine adding a breakpoint condition that's too expensive or incorrect. It might destroy your app in production. Just loading the variables in the watch can cause unforeseen problems in some cases. But this is the absolute worst. Say your app has a place where it takes user credentials for login. Maybe a third-party library you use does that. You can still place a breakpoint there and steal user login details. Worse, you can elevate the permission of your own user account because everything is writable. Just set a value of a variable. This goes against privacy laws and is very damn likely. 60% of security breaches in an organization happen because an employee. There are often misconceptions of security that look at the outside world only. This just isn't true. I didn't forget about this slide. This is an even more important aspect. Everything we discussed up until now assumes we know the exact container where a problem is happening. In real life, this is rarely the case. We can have thousands of containers in real-world deployments. How can you debug something like that? The debugger can solve depth issues well. It lets us dive into code despite all of the problems, but it wasn't built for scale or for production. That's where developer observability comes in. We used to call this continuous observability, but developer observability makes more sense. It's a new set of tools designed to solve this exact problem. Observability is defined as the ability to understand how your system works on the inside without shipping new code. The without shipping new code portion is key. With developer observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving the information. With developer observability, we flip that. We ask questions and then instrument based on the questions. So how does that work in practice? In practice, we add an agent to every pod. This lets us debug the source code directly from the IDE almost like debugging a local project. To start, we need to sign up for a free Lightrun account at lightrun.com/free. Notice that Lightrun has a very generous free tier you can use to experiment with the product. Pretty much everything I show here can be accomplished with a free account, and also probably with other developer observability tools which are available. You can check out Lightrun docs for more details, instructions on setting Lightrun and Docker, Minikube, etc. Unlike kubectl debug, we need to install the agent before the problem occurs. So if we do run into a problem, we'll be able to jump right into it. Let's skip ahead to a simple demo right in the IDE once the agent is set up. This is the prime main app in Kotlin. It simply loops over numbers and checks if they are a prime number. It sleeps for 10 milliseconds, so it won't completely demolish the CPU, but other than that, it's a pretty simple application. It counts the number of primes it finds along the way and prints a result at the end. We use this code a lot when debugging since it's CPU intensive and yet very simple. In this case, we would like to observe the variable I, which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. The simplest tool we have is the ability to inject a log into the application. We can also inject a snapshot or add metrics. I'll discuss all of those soon enough. Selecting log opens the UI to enter a new log. I can write more than just text. In the curly braces, I can include any expression I want, such as the value of the variable that I included in this expression. I can also invoke methods and do all sorts of things, but here's the thing. If I invoke a method that's too computationally intensive, or if I invoke a method that changes application state, the log won't be added. I'll get an error. After clicking OK, we see the log appearing above the line in the IDE. Notice that this behavior is specific to IntelliJ or JetBrains IDEs. In Visual Studio Code, it will show a marker on the side. Once the log is hit, we'll see logs appear in batches. Notice I chose to pipe into the IDE for convenience, but there's a lot more I can do with them. For now, the thing I want to focus on is the last line. Notice that the log point is paused due to high call rate. This means additional logs won't show for a short period of time, since logging exceeded the threshold of CPU usage. This can happen quickly or slowly depending on how you're observing. Let's move on to a different demo. This is the Node.js project that implements a backend in a microservice architecture. This is a method that gets invoked when we click a movie and want to see the details. This time I'll add a snapshot. Some other developer observability tools call this capture or non-breaking breakpoint. Same thing. Once I press OK, the camera button appears on the left, indicating the location of the snapshot, like you would see with a regular IDE breakpoint. Now I'll just access a portion in the front end that triggers this code. And now we wait a second, and the snapshot is hit. So what is the snapshot? It gives us a stack trace and variables just like a regular breakpoint we all know and love. But it doesn't stop at that point, so your server won't be stuck waiting for a step over. Now, obviously, you can't step over the code, so you need to step by individual snapshots. But this has huge benefits, especially in production scenarios. But this gets much better. This was relatively simple in terms of observability. Let's up the ante a bit and talk about user-specific problems. So here we have a problem with the request. One specific user is complaining that the list on his machine doesn't match the list for his peers. The problem is that if I put a snapshot, I'll get a lot of noise because there are so many users reloading all the time. So the solution is to use a conditional snapshot, just like you can with a regular debugger. Notice you can define a condition for a log and metric as well. This is one of the key features of continuous observability. I add a new snapshot, and in it I have an option to define quite a lot of things. I won't even discuss the advanced version of this dialog in this session. This is a really trivial condition. We already have a simple security utility class that I can use to query the current user ID. So I just make use of that and compare the response to the ID of the user that's experiencing a problem. Notice I use the fully qualified name of the class. I could have just written security, And it's very possible it would have worked, but it isn't guaranteed. Names can clash on the agent, and the agent side isn't aware of all the things we have in the IDE. As such, it's often good practice to be more specific. After pressing OK, we see a special version of the snapshot icon with the question mark on it. This indicates that this action has a condition on it, and now that it's just a waiting game for the user to hit the snapshot. This is the point where you can go make yourself a cup of coffee or even go home and check it the next day. In this case, I won't make you wait long. The snapshot gets hit by the right user despite other users coming in. This specific request is from that right user ID. We can now review the stack information and fix a user-specific bug. Due to the lack of time, I'll skip metrics and many other features. There's a lot more to discuss. Let's go back to the list of drawbacks we had with debuggers and review it again. You can keep an observability agent running all the time since it's designed for this case. Here we don't have breakpoints. Snapshots don't stop. They are secure by design and are read-only. So you can destroy the server and it will throttle you if you overuse CPU. Some services use Litron's support, like Litron, support PII reduction, which removes private information from logs and block lists, which prevents a user from debugging restricted classes or files. So in closing, I'd like to review some of the things we discussed today. kubectl debug made debugging crashed pods possible. It also made it possible to debug a pod based on bare bones image. KoolKits made kubectl debug easier to use with pre-installed tools. Debugging an application in an existing container in production is difficult and a risky process. Developed Observability made deep, secure, read-only real-time debugging at scale easy. So thanks for bearing with me. I hope you enjoyed the presentation. Please feel free to ask any questions, and also feel free to write to me. Also, please check out talktotheduck.dev, where I talk about debugging in depth, and check out litron.com, which I think you guys will like a lot. If you have any questions, my email is listed here, and I'll be happy to help. Thank you. Well, so.
Wow, that was I
rushed.
Like I've had to manage a kubectl cluster in production, and where have you been my entire life? Where was this?
Well, it's 1.23. Don't forget, for the kubectl debug, so it's really new, and KoolKits is even newer, and Litron is 2 years old actually. A bit sooner. I'm literally the first employee at Litron. So the whole field of developer observability.
I did a session. I was teaching some students at one of the universities in Bloemfontein. It's a small city in Johannesburg. And I lost my kube cluster. And I just lost it. It just disappeared. And right in the audience there, and I couldn't debug it, and I had no access to it, and no way to actually do that. And they looked at me and they go, no, never, no. But yeah, so this is a great opportunity to actually understand that you can actually get insight into that. So I want to bring out our next speakers who are dovetailing exactly off your talk, though. They're going to show us how to do and look at your containers, and then and measure and automate the process to scale your containers, which is a very important process.